Hi, my name is Makeda Duey. I'm a rising senior at Padua Academy.
And I'm Zion Walker, and I am a junior, and I go to Pickerington High School Central. We were participants of the NASA SEAS internship, and we were in the Urban Heat Island group. And for our research project, we decided to study carbon dioxide's effect on the urban heat island effect and mitigation techniques.
So we wanted to ask the question, does carbon dioxide emissions exacerbate the urban heat island effect? And how does vegetation play a role in mitigating both problems?
So, for some background information before we start getting into our research, carbon dioxide, or CO2, is the primary greenhouse gas that is released by human activity. What we mean by human activity is through like air conditioners or the burning of fossil fuels. The other thing is the urban heat island effect, is where urbanized areas experience a higher amount of temperature than the rural or outlying areas. Urban vegetation regulates climate by the shading provided by the leaves, and it prevents carbon dioxide from releasing in the air through photosynthesis.
So for our study area, we chose to focus on the state of Ohio. So we picked an urbanized city in Ohio and a rural city in Ohio. Uh, our urbanized city is Columbus, Ohio, and our rural area is Harrison, Ohio. So we chose the month of July in the year 2019 so that the data wouldn't be skewed by COVID and summer because CO2 emissions and plant vegetation would be relatively high compared to the rest of the year in the summer.
So for a methodology for a research project, we divided it up into different steps. So our first step was to find one major urban and one rural city. And then our second step was to use Landsat C1 Level 1 satellite imagery from July 2019, import that into QGIS, and pull out the NDVI in band 10 to compare surface temperature to vegetation. Our third step was to find carbon emissions data, which we found on epa.gov, and compare it to what we have found in step 2. And when finding the carbon emissions data, we averaged the points up from July 1st to July 31st, 2019, since the satellite imagery was also kind of like an average of the month of July 2019. For our fourth step, we decided to find trends within the three sets of data and to see if they relate to one another. Our fifth step is to identify how vegetation will mitigate both carbon dioxide emissions and the UHIE effect through analyzing research papers.
So here is NDVI, which is a normalized difference vegetation index. And on the scale, the paler the green means less vegetation, and the darker green means more is gonna there's gonna be more vegetation. So in the left photo we have Harrison, Ohio, which is very green and very little pale green. And on the right side we have Columbus, Ohio, which is much more much more pale or slash lighter green, showing that Columbus, Ohio has less vegetation than Harrison, Ohio.
So we also pulled out band 10 from Landsat data to discover what the land surface temperature was in 2019 for Harrison, Ohio and Columbus, Ohio. So for Harrison, Ohio, you see more of this bluish color all around, and that means it's closer. It's closer to 58 degrees Celsius, meaning that it is cooler. And for Columbus, Ohio, you see more of that like yellowish, orangish color, and that means that it's the land surface temperature is higher and it's just hotter there in general, and that's closer to 98 degrees Celsius. Reason why land surface temperature seems to be so high in both of these areas is because the device used to measure land surface temperature is measuring the amount of infrared radiation that reflects off of the ground and is not measuring air temperature.
When the data was graphed, we found that as land surface temperature goes up, NDVI goes down. And we found that NDVI and land surface temperature have an inverse relationship with each other.
So our carbon emissions data was from EPA.gov, and EPA used the AQS system. And for the month of July 2019, Harrison, Ohio averaged about 0.12 ppm of carbon emissions. For the month of July 2019, Columbus, Ohio averaged 0.32 ppm of carbon emissions. And the reason why the carbon emissions levels are so low is because the AQS system measures a specific coordinate point from July 1st to July 31st, 2019. So for analyzing the data, Columbus, Ohio had 2.6 times the amount of carbon emissions. And what does this mean in correlation to our research project? This means that the higher amount of carbon emissions can correlate with a higher land surface temperature, and a higher NDVI index score will result in a lower surface temperature and a lower rate of carbon emissions.
When looking into the literature in relation to carbon dioxide and vegetation, it was found that while CO2 can help plant growth, too much CO2 can also suppress their growth, hence leaving them unable to absorb carbon dioxide in the air. It also should be noted that vegetation should be a short-term solution to reducing UHIE and carbon emissions.
So for acknowledgements, we like to acknowledge our NASA Seas mentors that were a part of the Urban Heat Island group, and we thank them for teaching us about the Urban Heat Island effect and how to get the data we need for our research projects.
The best part about the NASA Seas internship was learning about the Urban Heat Island effect and learning how the UHIE affects human health. And in the future, I plan to study aerospace engineering.
For me, the best part about the NASA Seas internship was learning how to use QGIS and how to get the necessary data that we needed to complete this research project. I plan on studying biomedical engineering with an emphasis of environmental protection. So I would like to use what I've learned in the NASA Seas internship in my career. Makeda and I would like to figure out to what extent does greenhouse gases affect the urban heat island effect.
Here are some of the sources that we used to conduct research for this project.